All right, guys and gals, today what we're going to do is we're going to review equations, all the equations that we've dealt with. So let's start off by looking at one-step equations. All right, this is where we started our journey. And we said that the biggest thing about one-step equations was understanding the idea of inverse operations. So for example, that if in my equation I saw, say, addition, that I knew subtraction is how I would undo it. Or if I had a subtraction problem, then odds are we could fix that with addition. Contrary-wise, we also had some situations with, say, multiplication and division. And we said that if we had a multiplication scenario, that it could be undone by division. Or if we had a division situation, that we could undo it by way of multiplication. So again, the big takeaway from one-step equations was understanding this idea of inverses. And if we can do inverse operations, well, then we're pretty well set. So let's do a couple real quick examples just to jog our memory. For example, let's say I had something like 17 added to x is equal to 12. Now, hopefully you'd be able to do something like this, say in your head, but if not, we knew that inverse operations would come to our rescue. So in this case, we know that this is a positive 17, right? We're adding this 17 on. So to undo it, I could subtract 17. And remember, we said if we do something to one side of the equation, we have to do it to the other to keep it balanced and fair. So I'll subtract 17 here. Now, if you don't like that, if you don't like the subtracting 17, so I'll do it to this one. If you would rather write adding the negative, all right, that works as well. It means the exact same thing. I'll write both just to show that it doesn't matter. So if I have 17 and I subtract 17, that gives me 0. 0 added to x is just x. All right. And then on the other side of that, we've got 12 added to a negative 17. And if we go ahead and add those together, we get negative 5. So that's our solution, our final answer for the problem. And again, we used inverses. We've got a positive, we're adding something on, so we use subtraction to get that going. Now, let's move on. Let's try, I don't know. Let's try something with multiplication and division. So we'll kind of separate these problems here. I know, let's try something like this. How about negative 8 equals x divided by 8? Okay. So again, with a situation like this, it's perfectly okay to flip-flop it. I know some of you would rather not have x here. So if you want to rewrite it, that's fine. Just make certain that you write it exactly as you see it. So x over 8, we've got x over 8. On the other side, we had a negative 8, so we can write it as... So if you want to switch it, you can. So let's talk about our inverses. Notice this is a division situation. If that's the case, we're going to use multiplication to undo it. So I'm going to multiply by 8 here, and I'm going to multiply by 8 here. Let's start on the right, or excuse me, the left side. If I have 8 and divide it by 8, that's the same as 1. And 1 times x is just 1x. There is no sense in writing 1x down, because ultimately it's just x. On the other side, we'll take 8 and multiply it by negative 8, and that is a negative 64. And again, remember, with all of these situations, we can check our work. So for example, with this first one, if I took negative 5 and added it to 17, sure enough, that would equal 12. We've done it right. Or on this side, if I take a negative 64 in for x and divide it by 8, that gives me a negative 8. So we've done it correctly. So always check your work. There is no sense in taking a wrong answer. Let's try another one. So we'll sort of separate this out here. How about 20, and let's change the variable up. How about 20v equals 0? Well, hopefully you recognize what the answer would be here, but if not, let's work through it. So in this case, I've got a multiplication scenario. So there it is, we're multiplying, and we'll undo it by division. So what I'm going to divide by is what's with the variable. Because remember, I just want the variable by itself with a number on the other side. So this 20 has to go. So I'll divide by 20 here, and I'll divide by 20 here. So 20 divided by 20 is just 1. So 1 times v is v. On the other side, 0 divided by 20 is just 0. And of course, I could check that real quick. 0 times 20 is, of course, 0. Let's do one more. How about something like this? I know we've seen situations like this and some people were struggling. So we'll do 14 subtract a equals 8. Now, notice this situation is a little bit different than this situation. Just because we have subtraction here, remember, this subtraction doesn't apply to the 14. It's actually applying to a. I'm subtracting a, not 14. So I'm going to rewrite this as adding a negative a, just to remind me that this 14 is positive. So if I want to do the inverse, if I want to undo this addition of 14, then I'm going to have to subtract 14 from both sides. So a positive 14 subtract 14 is 0. So I've got the opposite of a, or negative a. We could read it either way. And then 8 subtract 14 is a negative 6. Now, this problem actually is a two-step problem, which is where we'll head next. Since there is no coefficient here, remember, we don't typically write the 1 in, but in this case, there is a 1, a negative 1. So to undo that, notice by multiplication here, we'll undo it by division. So we'll divide both sides by that negative 1, and this gives us a equals 6. We do not want a negative sign in front of a variable like that. That's no good. So ultimately, we want to divide by this negative 1, and that will give us a equals 6. And if we try that, if we plug it in, negative 6 there, so 14 added to negative 6, sure enough, is 8. So we've done our problem correctly. All right. After one-step equations, we moved on. And we moved into what we called two-step equations. And in this case, we used what we called the dating analogy. So let's write out a quick example problem and kind of work through it here. So let's say we had something like x divided by 5 added to 4. I don't know, let's make it equal 7. That works fine. Remember, we said each part of the equation at this point related to a character in our dating game. So this part right here, our term with the variable was the couple. And I know they're the couple because look how close they are. Look how close. Isn't that cute? Then we said what was being either added or in some cases subtracted was the friend. Because if you go on a date at your age, odds are you're not going just the two of you. You're probably got a friend or two tagging along. And then last but not least, we said it was in a movie theater, so odds are there were other people there, so we said this was simply everyone else. All right. And each of those ideas played into our date, and we ultimately said the first thing you want to do is get rid of the friend, and then the second thing you're going to do is split up the couple. Because when you're on your date, you definitely don't want your friend there, so you make them sit somewhere else in the movie theater. And then the couple, when they get back home, and there they are on the stoop waiting for a kiss goodnight, somebody's father usually comes out and splits them up. So if you can remember that quick story, then you're good to solve these. So let's actually solve this one. We'll do it over here. So we've got x over 5 added to 4 is equal to 7. So let's see what we get. Remember, the first thing we're going to do is get rid of the friend. So that is a positive 4. We're adding 4. So go back to our inverses. Since we got an addition situation, we're going to subtract. So let's subtract 4 here on both sides. Oop. And remember, by both sides, we mean both sides of the equal sign. We're subtracting on the left side here, and we're subtracting on the right side here of the equal sign. So 4 subtract 4 is 0, and 0 added to x over 5 is just x over 5. On the other side, we've got 7 subtract 4, that is 3. Excellent. Now we're going to split up the couple. Now notice, back up with our inverse operations. This is a division situation. So if I've got division, I'm going to use multiplication to undo it. And in this case, it's the 5 that needs to go. So that's what I'm going to multiply by. I'm going to multiply both sides by 5. All right. Well, 5 divided by 5 is 1. And we don't write 1 times x unless we need it, say for our work. We're just going to write it as 1x like this. And then on the other side, we've got 3 times 5. That is 15. And then we can always check our work. So 15 divided by 5, that's 3. 3 added to 4, sure enough, is 7. That's a good answer. Well, let's try another one. How about something like, let's get a little more traditional here. How about negative 6x subtract 2 is equal to, I don't know, let's make them negatives all the way across. How about a negative 86? Let's go big. All right. With a subtraction, I'm going to change it to adding the opposite, just to remind myself that is a negative value. So we've got negatives across the board. So again, if I've got a negative situation, right, or a subtraction situation, I'm going to add. And remember, we always get rid of the friend first. So I'm going to add 2 to both sides. We'll send that friend packing. And notice I did to the left side, now I'm doing to the right. So negative 6x is all that's left here after all this zeroes out. And on the other side, notice this is a negative 84. Again, a negative 86 added to a positive 2. So if you owe $86, add 2 onto that debt. Remember, that's going to help that debt decrease. So now we're down to only $84 that you owe. All right, so the next thing we've got to do is split up the couple. Notice they're multiplied together here, so we're going to undo it by way of division. So let's divide both sides by negative 6. So here on the left, it's easy. Negative 6 divided by negative 6 is just a 1x. And then on this side, we've got negative divided by negative, so it's definitely going to be a positive outcome. Let's see, 6 goes into 8 once with 2 left over. 6 goes into 24 4 times. So there we are, our final answer. And then we can take that and plug it back in and see that, yes, both sides will indeed equal a negative 86 when we're done. So we're good. All right, after that, so we did 1 step, we did 2 step. After that, we went into multi-step. Ooh, there we are, multi-step, if I could write today. And we said that ultimately our flow chart was the way to go. So I've got a copy of one here. We said our flow chart is the way to go. This is ultimately going to help us step by step by step work through the problems. Now, I'm not going to keep one of these on screen the whole time, but if you've got yours, take it out. Make certain that you are following it. A lot of you on our quiz the last go around weren't following this, and it was very obvious based on the work I saw. So make sure you follow it. It's going to help you with probably 90 to 95% of your problems and getting them correct. Use one. So I'm going to set that off to the side. Let's look at a quick multi-step situation. I don't know. Let's get crazy here. How about negative 6 added to 8m equals a negative 6, parentheses, 1 subtract 3m, close parentheses. So I'm going to say what's on the flow chart, and if you've got yours handy, let's follow along. So the first step is to get rid of any subtraction issues, and I definitely have some here. So I'm going to add a line, change the sign, just like we've been doing before. So that's done. Second step, grouping symbols. So notice I've got some parentheses here that I can distribute. So negative 6 times 1, negative 6 times that, negative 3. And notice I'm drawing those arcs to remind myself I have to multiply both of those inside terms. So let's start rewriting. Negative 6 added to 8m, since these haven't changed yet. Negative 6 multiplied by 1 is negative 6. Negative 6 multiplied by a negative 3 is a positive, in this case, positive 18m. All right, flow chart, third step. Do you have a variable on the right? And in this case, we do. We definitely have a variable here. So what I'm going to do next is get rid of it. So since, notice, we're adding here, I'm going to use subtraction. So I'm going to subtract 18m from both sides. Well, let's see what we get. Negative 6 stays, nothing's happened to it. And notice, guys, I'm not taking this 18m away from the 6 here or the 6 there. That doesn't make sense. We can't do that. Make sure you're taking away from like terms. So the negative 6 stays. Let's see here. 8m subtract, adding a negative 18m there, that would be a negative 10m. And then on the other side here, 18 subtract 18 zeros out. 0 added to negative 6 is still just negative 6. All right, that was easy. We're on to our fourth step. We got our variable here, and we got a number not attached. So this negative 6, notice this is a 2-step. We're back to a 2-step. Here's the couple, there's the friend. So let's get rid of the friend. It's a negative, or subtracting 6 here, so we're going to add. So in this case, I'm going to add 6 to both sides of the equal sign. Notice here on the left and here on the right. Let's see what we get. Zeros out here, we'll keep our negative 10, there we are, negative 10m. And on the other side, that also zeros out, and that's okay. Guys, it's perfectly acceptable for us to have a 0 on a side by itself. It's a number just like anything else. Last step, do you have a number attached to the variable? In other words, do we have a coefficient? We definitely do. In this case, it's attached by multiplication, so we'll undo it by way of division. See those inverse operations come back into play. So we'll divide by negative 10 on both sides. M equals, and 0 divided by negative 10, what do you know, is 0. So we literally did all that work for, well, nothing. But again, we can double check ourselves. If we bring it back up here, 8 times 0, since that's what we got, is 0. Added to -6 is -6. So this entire side on the left is worth a -6. Let's try it over here. 0. 0 times negative 3 is 0. 0 plus 1 is 1. 1 times negative 6 is negative 6. So both sides equal negative 6. We're good to go. All right, let's talk about the last idea. This last idea that we dealt with equations dealt not with the type of equation, but with solution types. And we said that there were 3 different solution types, right? The first type is that you'll have one solution. And we know that we'll have one solution if we can get our equation, for example, say something like 2x added to 2 equals 3. So long as we can get our situation, our equation down to an x on one side, then we know we will have one solution. So ultimately, we could solve this to have x equal a number, and that's a one solution scenario. And we won't go through that particular problem. We've just done a whole bunch of those. That was one solution. Let's talk about the second option. All right. Our second option is a situation where we end up with a situation, how shall we say, that we have infinitely many solutions. In other words, it doesn't matter what x is. X can be anything. And here's how we spot that anything situation. So let's try one. 14 subtract 6m equals, let's see here, 7 parentheses. I got an example that I rewrote. 2 subtract m, close parentheses, added m. Cool. Let's work through that. So the first thing we'll do is get rid of that subtraction. Then we'll do some distribution. So 14 subtract 6m equals 14 added to negative 7m added to m. Well, those are like terms. We can combine those. So 14 subtract 6m equals 14. Negative 7 added to 1 is negative 6. And we said stop right there. Notice both of these, if we rewrote that subtraction, are identical. So when we have a situation like this, m in this case could be any number we want. For example, if I made both of these m's just 1, well, 1 times negative 6 is negative 6. 1 times negative 6 is negative 6. And if we do that, notice we get 14 added to negative 6, which is 8. Both sides are the same. What if I made m 10? Well, if I have a negative 60 here and a negative 60 there, once we multiply, negative 60 added to 14, it's going to be the same. So in this case, I could say m is all real numbers. Or that this situation has infinitely many solutions. We can pick any number we want for m in this case, and it's going to work. Right? And we said that we could stop our work at this point when both sides are identical. And then we could simply say that m is all real numbers, or we could say that, hey, our situation has infinitely many solutions. Well, let's look at the last one. All right? Our last situation, what if it's not one solution? What if it's not infinitely many solutions? What if there is actually no solution? In other words, x can't be anything and still work. Let's look at an example. So in this case, we'll do, let's do negative 4 multiplied by x added to 8 is equal to a negative 26 subtract 4x. All right, so let's change that. Add a line, change the sign. We'll do some distributing here. So negative 4x added to negative, what is that, 32 equals negative 26 added to negative 4x. And we said stop right there. Notice the coefficients are the same. So 4x here, 4x here, they're the same. So they're in balance. But on this side, I take away 32. On this side, I take away 26. Now think about that. If I've got two items and they are equal, but on one side I take away more than the other, suddenly they're out of balance. Okay, there's no way those two sides are actually equal. And if I take this equation a step further, let's add 4x to both sides. We can see really quickly where the problem is. 4 added to negative 4 zeros out, I'm left with negative 32. 4 added to negative 4 zeros out, I'm left with negative 26. And notice, negative 32 is not the same as negative 36. So in this case, we have no solution. There is no way that I can pick a number for x to make both these sides equal out. Notice, they both have a negative 4x. That means they're balanced. But because of this 32 and negative 26, it doesn't matter what x is, we're always going to be slightly out of kilter. All right? So in situations like that, we don't have to work any further. If the coefficients are the same and constants are different, no solution. So today, all we're going to be doing is reviewing our different equation types. So we'll be looking at one-step, two-step, and multi-step, and as well as our solution types, whether we have one solution, no solution, or infinitely many, and just reviewing how to do these things. If you have any questions or concerns, please let me know, and we'll take care of it.